So we are now going to move to the last part of this chapter, context sensitive spelling correction. Now context sensitive spelling correction is going to detect spelling errors of this form, where each word is spelled correctly, but instead of the query being flew from Heathrow, it's going to be flew from Heathrow. So every word taken in isolation is a valid word in the dictionary. But if you look at the phrase as a whole, it's not grammatically accurate. Okay, so a context sensitive spell corrector will fix this, will change this to flew from Heathrow. Now Google does context sensitive spelling correction, and even Office my versions of Microsoft Office after 2007, they have context sensitive spelling correction. Before 2007, they didn't have context sensitive spell correction. They only did isolated word correction. But after Office 2007, they've added context sensitive spell correction, and that was in fact one of their main features, one of their main new features. So it was projected as a pretty cool thing. And again, we are going to trigger the spell correction algorithm based on the fact that there are very few documents matching the query. So here's a simple way to do context sensitive spelling correction. Now context sensitive spelling correction is going to use isolated word spelling correction, but it's going to do something more than just isolated word spelling correction. So we're going to use ideas about weighted edit distance that we just saw. And in fact, even Jacquard coefficient. You can think of using either of those two approaches here. What we will do is, if we have, let's say we have three words. Okay, let me just call this as W1. Oh, sorry. This as W1, this as W2, this as W3. Okay, three words in the query. What we will do is, we will retrieve all the dictionary terms that are close to each of the query terms. Okay, so if we have W1, W2 and W3, okay, so we could have four terms in the dictionary that are close to W. We could have three terms in the dictionary close to W2 and five terms in the dictionary close to W3. Okay, so these are the spelling suggestions for W1. These are the three spelling suggestions for W2. These are the five spelling suggestions for W3. And these are all isolated word spelling suggestions. Okay, using the techniques we just discussed. Could you please switch off the microphone? Yeah, thank you. Now once we have all the spelling suggestions for each word in isolation, we will take each of these suggestions one by one and combine them in all possible combinations. Okay, so I could take the first spelling suggestion for W1, combine it with the first spelling suggestion for W2 and the first spelling suggestion for W3. Okay, that would be one possible spelling suggestion for the phrase as a whole, W1, W2, W3. I could take the first spelling suggestion for W1, combine it with the second spelling suggestion for W2 and the fourth spelling suggestion for W3. That would be another spelling suggestion for the phrase as a whole. So that way you could try all possible combinations of spelling suggestions for the individual words and come up with a list of spelling suggestions for the phrase as a whole. So here's a question. Suppose we have 7 spelling suggestions for flu, 19 for form, and 3 for Heathrow. What would be the total number of corrected phrases that will result according to this scheme?
So if it was one at a time, it would be 29.
Okay, if it's only one at a time, well, what I described was a combination. So you'll take this, combine it with any of this and with any of this. So that would be 7 times 19 times 3.
199, sir. 199.
Okay, yeah. So that will be the product of these three. Now, obviously, you won't give all 199 of them as spelling suggestions. You'll again look at the collection frequency of the phrase as a whole. Okay, you'll look at how many times that particular each of those 199 phrases occurs in your corpus. And based on that, you will rank the spelling suggestions and maybe just pick the top few. Now there's a modification of that. Could you please put the mic? So this is called a hit-based spelling correction, where you take all the enumerated phrases and you decide which is the good suggestion based on the number of hits in the corpus, how many times that phrase appears in the corpus. So if there are some phrases that appear much more frequently than other phrases, you will just present those as spelling suggestions. Now, this hit-based spelling correction can be done in two ways. You could look at the number of hits for each of those suggestions in the corpus, as I just said. Alternatively, you could look at the number of hits for each of those spelling suggestions in the query logs. Okay, in the corpus. And the second possibility is in the query logs. So the query logs are the logs of all the past queries by various users. So you could look at which of those spelling suggestions have been historically made by many users, and if many of the users have tended to make one of those spelling suggestions as the query, then you'll suggest only that one, right? So actually it's not important how many times the phrase appears in the corpus as how many times it appears in the query logs, because this tells you you're doing spelling correction on the queries, right? You're not fixing spelling mistakes in the documents. So if you're fixing spelling mistakes in the query, it makes more sense to look at query logs than at the corpus. It makes more sense to look at the hits in the query logs than hits in the corpus. Now there's an optimized version of the method that I just described, where you don't look at 7 times 9 times 3 combinations. You just fix the first, you just enumerate the 7 suggestions for the first term, and then choose the one or two of them, choose just one or two of them which are which have more hits than the others. Okay, so among these 7, maybe one or two of them have a much larger number of hits than the other 4 or 5 alternatives. So you'll just choose those, and then you will you will combine these one or two with these 19, and then figure out which of these bywords. So you will generate about 19 or 38 bywords, and you'll figure out which of these bywords are most common. Again, in terms of number of hits in the query logs. And maybe, out of those 38, only maybe one or two of them could be could have a large number of hits relative to the others. So then you will work with only those one or two bywords and then add the spelling suggestions for the third term. Right? So if you do that, you can cut down on the number of possibilities. Again, you can think of variants of this. Maybe you can, if you make the assumption that in any phrase query, only one of the words needs to be corrected. Okay, that's a possibility. You could, maybe argue that users won't have spelling mistakes in all the three words. They will have spelling mistakes in only one of the three words. In that case, you can just try correcting the words one at a time. Okay, just correct the first word and generate the 7 possibilities. Then correct the second, just correct only the second word and generate 19 possibilities. Then correct only the third word and generate 3 more possibilities. In that case, you will have 7 plus 19 plus 3, which is what somebody was saying a few minutes ago. Right? So it all depends on what works. Okay, empirically, I mean, rationally, it's very hard to argue um which of these is going to work best, because that depends on the assumptions, how accurate your assumptions are about what sort of spelling mistakes users make. Okay, if you can see that you could ideally generate all 7 times 19 times 3 combinations, but then your system will have to do a lot more work.
Hello, sir.
Hello.
It's your time. It's time for the next class, sir. Can you?
Okay, actually we
Hello.
are done. So we have finished this chapter, and you can just ignore this part. We'll come to this part later on in the course. But I think we basically finished this chapter. So this is an exercise that you may want to try out. Think of how you would combine all the approaches that we've discussed in the 3 chapters to answer a query like this. Okay, you're
Thank you, sir.
combining spelling correction with proximity queries, with wildcard queries, Boolean queries, soundex.